Actually, I have the ACT on Sunday. I'm taking this as my last. Like I can try. I took that in May. And so I'm like, why did I sign up for this?
That's exactly why I tried for this one. I was like, okay, I know it's like, it's not gonna get any better.
That's good. I don't know, like my parents. So, because it's really. So today, I'm getting my and then I think my husband is gonna speak all of them. Yeah,
That's.
Yeah, if we can't meet in that room, we can meet in here. So it'll be one of those three. If I can get that unlocked, I'll try to get that unlocked.
So when I think we're just so and so I can't be governed.
Yeah.
I can't get above 20.
Oh, mine.
Okay,
My math.
we're moving to unit 3, but really unit 3 is just an extension of unit 2. There's only 2 sections that we have to add on to that that we need to do with unit 3. So we'll do chain rule today, and then we'll do implicit on Friday, and then we'll get to spend the entire next week reviewing. Okay. I hope to get back yes, your quizzes tomorrow. I hope to get back your quiz, if not Monday, then Tuesday. And that way you can see what you did before we get into our test. Okay. This won't take the full period though, so we can spend some time going over our review worksheet 3 that you guys picked up yesterday. Okay, so page 1. The chain rule, this is we found derivatives when we have different expressions that are related to each other, either through multiplication, which we use product rule, through division, which we can use quotient rule. But now we have composition. So what happens if I have a function within a function? And so to handle that, we go through chain rule. So the method of computing the derivative of a composition of 2 or more functions. So basically a function within a function. So here is the function notation for how chain rule works. So notice that if I have a function that looks like this, f of g of x, basically there's an inside portion within an outer expression. Then the derivative is basically we take the derivative of the outside function, okay, derivative of the outside function, while keeping the inside portion unchanged. So that's what that f prime of g of x is doing. So we take care of that outside f prime, but we leave the inside unchanged. Next up, we multiply the derivative of the inside function. Next up, we multiply whatever the inside function is, it's going to have its own space for its own derivative. Let's look at example 1 and see what the benefit of chain rule is. So if I have f of x equals 3x squared plus 2 to the 5th power, if I didn't, if we're only relying on rules that we learned in the past, what would we have to do if we wanted to find this derivative? Let's say we want to use power rule, right? If we want to do power rule, what needs to happen before we can do power rule? Yeah, we got to fold all that out, right? And that will take a long time. I mean, I would expect you to be able to do it if it's 3x squared plus 2 squared, but anything higher than the second power, I mean, there are ways that we can do it, like Pascal's triangle, but we don't have to worry about that in this class. Okay, anything that's higher than the 2, we want to explore alternatives. So the alternative is we think of this as a function within a function. So what I mean by that is there's an outside portion. The outside portion is basically whatever is outside the parentheses with the exponent included. So imagine there's an outside portion that is that parentheses to the 5th power. And then there is an inside portion that is 3x squared plus 2. So we're essentially going to be taking turns with each derivative. So now treat the parentheses as its own variable. Parentheses to the 5th power. So we can just go through power rule for this portion, right? What would the derivative for parentheses to the 5th power be? Treating this as just its own variable. It'll be what? Or what's the derivative of x to the 5th power? 5x to the 4th. So therefore, what's the derivative of parentheses to the 5th power? 5 parentheses to the 4th. So we're pretending, or we're treating this notation as its own variable. So 5 parentheses to the 4th power. So that's what this is doing here. This is taking care of that outside derivative, that f prime. What do you think we're going to put inside this set of parentheses based off of what the rule says? Yeah, the original function, okay, because we're not ready for this derivative just yet. So we took the outside derivative, which is parentheses to the 5th power. We did 5 parentheses to the 4th. And now we're moving into that inside portion, which is 3x squared plus 4. Now that we're done with the outside portion, we can have a separate space for that inside derivative, that g prime. So what's g prime going to be? What's the inside derivative? 6x, yeah. Okay, so that's how we do chain rule. I can do a little bit of cleanup. I can merge the 5, put the 5 and 6x together. This is my derivative. A lot more efficient than having to FOIL all this out, find the derivative, and factor everything back to this form, right? We can save a lot of time going through chain rule, especially if we can identify an outside inside portion. Any questions with that? I do want to talk about a common mistake that students experience with chain rule. And this is common mistake is where students would recognize that there's chain rule going on. And then so they would say, okay, outside derivative is 5 parentheses to the 4th power. But I want to be more efficient. So I just go ahead and find this inside derivative, which is 6x. And then I'm able to get something a lot more efficient, but we can't do that. Okay, so the derivative requires us, for chain rule, when we take the outside derivative, we're actually going to have to hold on to that inside function. It's going to have to show up within that inside function. And then when we find the inside derivative, it's going to be in its own separate space away from the outside portion. So make sure that that we don't just put that inside derivative in the parentheses. It's going to be outside the set of parentheses. The inside will will remain there, at least for the first portion of the problem. Okay, example 2. Find all the values of the function for which f prime is equal to 0 and where f prime does not exist. So f prime is equal to 0. This is basically where the slope is 0. And if there's a numerator and denominator portion within my f prime, then it's going to be coming from my numerator. So my numerator of f prime is going to be telling me where my slope is going to be 0. F prime does not exist. That's basically mean slope undefined. And the way I find slope undefined, or places where the slope could be undefined, is I'm going to be setting the denominator of f prime equal to 0. So numerator of f prime will give us places where the slope is going to be 0. The denominator of f prime will be potential places where the slope is undefined. Slope is undefined could be like a sharp point or a vertical tangent. But first things first, we're going to find the derivative. All right. How can I rewrite this function here? Can I rewrite this without radicals? What would that look like? X squared minus 1 to the what? To the 2/3, right? Now, if I want to find this derivative, we actually are stuck not being able to, I mean, even if we wanted to expand, we could expand the first one. This is doable, but this we can't expand, right? We don't have a ability to expand this out. So this one is where we can't do power rule, even if we wanted to. That exponent doesn't allow us to expand. So we're forced into chain rule to find the derivative. So we have to identify the outside portion. And then we'll do the inside portion. And then we'll take turns with each derivative. All right, so let's walk through the chain rule here. All right, what's outside derivative? What's parentheses to the 2/3 derivative? Okay, power rule, right? So bring the 2/3 down. We keep the parentheses, keep the inside function. What's my new exponent going to be? -1/3 times. So now we're done with the outside portion. We can now move on to the inside portion. What's the inside derivative going to be? Just what? Yeah, just 2x. Okay, so there's our derivative. All right, let's do some cleanup so we can actually figure out what the numerator and denominator portions of our derivative will look like. So we can actually find this information. So I'm going to place the numerators together and my denominators together. So it looks like the 2 and 2x, they're both in the numerator. I'm going to merge them together, make it 4x. The 3 is in the denominator. And I'm also going to put that x squared minus 1 in the denominator because it's got that negative exponent. I want to resolve that negative exponent. So x squared minus 1 to the 1/3. So this is my slope formula for this original graph, for my original function. Now, if I did not have a denominator, I would just be able to set the entire derivative equal to 0, and that will tell me slope 0. But if I'm looking, if there's a numerator and denominator, then just know that your numerator is going to be a place where you can find slope zeros, and denominator is going to be a place where you can find slope undefined. Right? Whatever is 0 in the denominator is undefined, so that will cause my slope to be undefined. Okay. So I want to find values where f prime is equal to 0, so I'm going to set the numerator equal to 0 to find that. What happens if I set 4x equal to 0? X equals what? X equals 0. Yeah. Okay, so that's the first part of my, I've answered this portion of my problem. And now where the slope does not exist, now I'm going to be looking where? The denominator, right? Set the denominator equal to 0 of my derivative. So I can divide both sides by 3. I can cube both sides. I can solve for x. What do I get for x? X equals what? Good, plus or minus 1. Anytime I take the square root of an equation, there's going to be a plus or minus 1 that shows up. So we can say f prime is undefined. The slope is undefined. At x equals 1 and x equals negative 1. Okay, before we move on, I think it's nice to look at the graph and be convinced that this actually is true. So this is what the graph looks like. This is what cube root of x squared minus 1 squared looks like. So I want us to look at this and be convinced that this is actually giving information that we can visualize. So we found that the slope is 0 at 0, which we know that to be true, right? So if we look at the graph here, this is the graph of my original function, cube root of x squared minus 1 squared. We see that to be true, right? We see that this is definitely a slope 0. And then we see that we found through calculus that the slope is undefined at 1 and negative 1. And we do see sharp turns on the original graph. So that's consistent with what we found algebraically and through calculus, right? Slope is undefined at negative 1 and 1 because of the sharp turns. We're able to find where slope is 0 by setting the numerator equal to 0, and we found that location x equals 0. All right, next page. Example 3. Find the equation of the tangent line to the graph at x equals -3. So we have to gather two sets of information. We're going to find the ordered pair, and then we're going to find the slope. Let's do the easy part first. Let's find ordered pair. So plug -3 in for x. Okay, so there's my ordered pair. My ordered pair is -3. Sorry, yeah, -3, comma 4. Next up, I want to find the derivative. To get to the derivative, I could go through quotient rule, but the nice thing about this problem is that there's only a constant up in the numerator. So I can avoid quotient rule if either the numerator or denominator is missing a variable. Right. So I really only have to worry about quotient rule and forcing the quotient rule if there's a numerator and denominator and they're both showing a variable. So I'm going to force that x plus 2 up to make it so that I don't have to go through quotient rule. So this is the same thing as saying 4 times x plus 2 raised to what power? If I bring that x plus 2 up. Raised to what? Yeah, -2, right? So these are the same things. We haven't done anything to change the value of the function. We just made it so that we can go through, we can avoid quotient rule. So here, if we want to find the derivative, notice that we can't expand this out, right? That's -2 here. But what we can do is we can identify outside inside portion and go through chain rule. So there's an outside portion, which is that 4 parentheses to the -2. Basically anything, including parentheses and outside of it, is my outside portion. And my inside portion is the x plus 2. Okay. We find our derivative. We take turns with each derivative. So what's the derivative of 4 parentheses to the -2 if we just do power rule? What's that going to give us? Okay, bring the exponent down. What does that give us? -8 parentheses to the -3. Yeah. So we get -8 parentheses to the -3. What goes inside here? Good. We keep the original inside. We're not ready for that yet. We're not ready for its derivative yet. So this takes care of my outside portion's derivative. Now I'm ready for my inside portion. So what's x plus 2's derivative? Just what? Just what? Okay, so there's my y prime. Okay, I'll clean up y prime, plug -3 in, get the slope, and then we can do point slope form. So there's my slope formula, my derivative function. I'm going to now find the slope using my slope formula, plug -3 into my derivative. I'm going to make my way down to 8. So now I have everything that I need. I have my ordered pair, I have my slope, and now point slope form. Okay, let's do one more example here. Example 4. Okay, we have x minus 1 over x squared minus 4 raised to the third power. This is complicated enough where we know we have to rely on chain rule because we can definitely see an outside-inside portion with this problem. So the outside portion is parentheses cubed, and the inside portion is the x minus 1 over x squared minus 4. So this, we can do power rule, just like we've seen before. But what's required to get to the inside derivative? What rule? Push rule. Okay. All right, so let's try that. Y prime equals outside derivative first, power rule. So 3 bracket squared. What goes inside here? Good. I do want to keep pointing that out because a lot of students want to do the derivative of this and put it inside this space. So we want to keep reminding ourselves that when we take the outside derivative, the inside portion is going to remain. It's not going to transform into the derivative until later. Okay, so that's the outside derivative. So now the inside, you guys mentioned chain rule, quotient rule. So I'm going to label and we're going to build out quotient rule. Okay, so one piece at a time, f prime. F prime is x minus 1's derivative, so that's just going to be 1. G function, no changes. Back to f, no changes. Back to g prime. G prime becomes what? X squared minus 4 becomes 2x. Okay, all over denominator squared. Don't forget, quotient rule has that denominator squared portion as part of the derivative as well. Okay, as far as cleanup goes, we're just trying to merge all this into one fraction, but really the bulk of the cleanup work is just trying to get this to be a little merged together better. So I'm just gonna step to the side here and just focus on this part and just try to get that part cleaned up and we can put it back into the problem. So this is really just x squared minus 4. I'm going to distribute the 2x through the x minus 1. So I'm just going to take this cleaned up version and replace this portion there. Okay, so I'm ready for my cleanup, trying to get everything down to one fraction here. All right, so I'm going to put all the numerators together and all the denominators together. So the 3 is going to be in the numerator. And here, I can just call this what? X minus 1 to what power? The second. You can put that in the numerator, separated from that x squared minus 4. And then finally, I can put what I highlighted, cleaned up, also in the numerator. Now in the denominator, I have 2 sets of x squared minus 4. But let me ask you, how many x squared minus 4 are there? It looks like 3, but it's really what? There's 2 here. How many x squared minus 4 do we have here? 2. So we have total of what? 4. I want to point that out because I think that exponent is far away from that denominator where we feel like we're not seeing that 2 as well as we see it with the x minus 1, just make sure that we pay attention to that exponent. Okay, so that's a common mistake that when students combine this together, they forget to check that number up top. And there's 2 of them here, the 2 of them here, we add those exponent, ends up giving us 4. Okay, there's homework with chain rule, but I'm not going to check it until Friday. But I will send out a reminder tomorrow afternoon that I'll be checking chain rule homework. Okay, I like to use the rest of the time to continue reviewing for your quiz for tomorrow. So if you guys can have out worksheet 3, what you picked up yesterday. Did everyone have that worksheet 3? Anyone else need worksheet 3 yesterday? Okay, so number 1 is power rule. We can expand that out. We'll do that later. I want to focus our attention on number 2. You're going to see a problem like this. Okay, we're looking at number 2. Even though there's a numerator and denominator components of this function, I'm going to specify on the quiz that you're going to be using power rule for this. You're not going to use quotient rule for this problem. But to do power rule, we have to take the time to expand everything out because there's a lot going on with this problem. We want to basically split this up into smaller problems so that we're not having to deal with this giant mess. But that requires us to clean up. So I'm just going to distribute the 4x through to begin with. And the denominator, this is what? Square root of x to the 9th is x to the what power? 9/2. Good. 9/2. We read from right to left. That missing root is a square root, is 2. Okay, so as I distribute, I'm going to be adding exponents. 1 plus 1/2 is 3/2. And then as I do that, I can also begin separating into individual fractions. There's only one term below. I can assign the denominator to each of the numerators. Okay, so what we've done, what we've accomplished so far is we basically took this messy problem and split it up into 3 smaller problems. We'd much rather do 3 small problems than trying to do one large one. But we're still not ready for power rule yet. What is out of place that we have to move? What do we see that has to move if we want to do power rule? Okay, where do the variables have to be if we want to do power rule? Numerator. So we have to move the x up to the top. Do we have to move the 5 as well? No, the 5 is fine. The 5 is in the denominator. That is not causing the issue. It's that x. So how can I merge the x's together? By doing what with the exponents? Subtract. That's right. So if they have common denominators, then we can go ahead and subtract. If they don't have common denominators, we have to create common denominators before we subtract. So 3/2 minus 9/2 is -6/2. Now, as we do this, we haven't done any calculus yet, so we don't want to just let this be our final step. We still have to finish our calculus portion. So 3/2 minus 9/2 is -6/2. And then 2 minus 9/2, that's the same thing as 4/2 minus 9/2, right? So 4/2 minus 9/2 is -5/2. So that's going to be my new exponent, plus 12/5 x to the -5/2. And finally, I have x to the first power over 9/2. So first power is same thing as 2/2 if I want to match the denominator. So 2/2 minus 9/2 is -7/2. So among the mistakes that I see students make is they feel like they've gone through so many steps that they feel like they've done enough, and so they would circle this as the answer. But we haven't done any calculus yet. These are all the same thing, but this is just written in a way that is set up for power rule. I'm going to clean that up a little bit more. That -6/2 is actually going to be what? That's just -3, so I don't have to hold on to that fraction there. So I'm going to rewrite it one more time, and then we can do power rule. Okay, so now we're ready for power rule. So power rule, bring down the exponent, subtract 1 from the exponent, bring down the exponent, subtract 1 from this exponent, bring down the exponent, subtract 1 from this exponent. Okay, bring down the -5/2. Okay, what's my new exponent going to be if I subtract 1 from -5/2? -2/2, so that's -7/2. Bring down the -7/2. And then my new exponent, subtracting 1, will be -9/2. Okay, now that we have our derivative, we're just going to try to clean up, pushing the negative exponents back down to the denominator. And then if I can clean up my coefficient, I'll do that as well. The 5s cancel out, the negative stays, 12/2 is 6, so it's -6 over x to the 7/2. And then 28/10, I'm going to reduce that to be 14/5. Oops, sorry, I lost the negative here. Yeah. Plus. I think my key is a little bit off. My sign is off on the key, so that should be a plus there. I find that this is the problem that takes the most practice. So in the time that we have, can we can we do another one of these problems? So if you guys can find another sheet of paper for you guys to write this down. All right, let me call. Okay, so go ahead and we're going to expand that numerator. Make sure that you expand correctly. You have to FOIL out the x plus 1 squared first before you distribute the 4x through. Okay, so try your first steps before I show my progress. Okay, check my work as well as I'm working through this. Is that what you guys are getting? Okay, so I have to get this ready for power rule, so I have to merge the fraction by subtracting, and I need to do common denominators if the fractions are not matching denominators. So 3 is gonna be a 6/2. 6/2 minus 5/2 is 1/2. 4/2 minus 5/2 is -1/2. And then 2/2 minus 5/2 is -3. So now every term is up to the starting line, so we can do power rule. So now we find the derivative, do power rule, and do some cleanup. But I think the hardest part is get to this stage, right? Can you get the cleanup all the way to this point so that every term is ready for power rule? Okay, double check my work. Is that what you guys are getting? Yeah, this is the most labor intensive problem on the quiz. So I want to just go through a couple of this. We'll do another one tomorrow in our morning review, but does that process make sense? All right, so tonight, I want you guys to study for your quiz. If you haven't gone through worksheet 3, then try working through that. Tomorrow morning, I'll do worksheet 4. I'll have a morning review at 7:15. Okay, all right, come get your phones. Quiz is tomorrow, no calculator.